In this video, we'll be talking about the difference quotient. The difference quotient is a huge idea in calculus with derivatives, but in pre-calculus, we are going to talk about it. It's not going to have a ton of meaning yet until you get to calculus, but just understanding how to do things like evaluating functions at a variable expression, factoring out a GCF, all of this prerequisite information is going to help you succeed with the difference quotient. So we'll start with doing just a quick review before we get to actually what it is. The first thing that we'll review is greatest common factor and how to factor it out. So I have two examples here. What we'll do is we'll factor out the GCF of each one of these expressions. In the first expression, let's figure out what our greatest common factor is. It's the greatest value that is common to both and is a factor to both. So if we look at 15 and 3, we see that, okay, the factors of 15 are 1, 3, 5, and 15. The factors of 3 are just 1 and 3. The greatest one that they have in common then is 3. Basically, 15 and 3 can both be divided by 3. All right, then we look at the variables. This term has an x squared, this term has an x. The greatest that they have in common is just x. They don't have an x squared in common because this term does not have an x squared. So 3x is our greatest common factor. Then we're factoring, we're basically reverse multiplying or reverse distributing. We want to think, hey, what do I need to multiply 3x by in order to get this expression back? So 3x times what will give us back to 15x squared? And that answer is 5x. 3x times what will get us back to minus 3x, and that's just a minus 1. So we've successfully found the GCF, 3x, and we've successfully factored. If you ever want to check your work, go ahead and distribute this back through, and you will get back to the original. In our second example, the greatest common factor between these two terms is h. That's the greatest thing that they have in common. So h is the GCF, and what remains in each term, we're reverse distributing. H times what will get us xh, that's x, and h times what will give us 2h, or plus 2h, and that's a plus 2. I use h in this review because h is a part of the difference quotient, and it will be something that we'll be factoring out. Okay, number 2 in our review before we get to the difference quotient is evaluating a function at a variable expression. And so we're pretty good, and we've seen a lot of evaluating like f of 2 or f of 7, like plugging in a number. But sometimes students struggle with plugging in an expression because it's just a little more complex. So let's say we have the function f of x equals 3x minus 5. And we want to find f of x plus h. Well, that means we have to plug in x plus h everywhere there's an x. And since it's an expression, we'll put it in parentheses. And then we can multiply the 3 through, distribute it through. And then we're done. We can't simplify this any further because there's no greatest common factor to all 3 terms. There's no parentheses anymore to distribute. We already did that. So this is a simplified final answer. But let's say our function was a little more complex than that. Let's say perhaps it was a quadratic function. Let's say we have x squared plus 2x minus 4. All right, so let's say we have this quadratic trinomial, and we want to plug in x plus h. Evaluate the function at x plus h. That means I'm going to first square x plus h, then distribute a 2 through x plus h, and then I still have a minus 4. The biggest area that students will make errors in is squaring x plus h. So in order to square this, we need to multiply it by itself, x plus h times x plus h. That's what I'll focus on first. When we multiply something by itself, right, we're squaring it, so we need to distribute. So we're going to do x times x, and then x times h. So we'll get x squared plus xh. Then we'll distribute the h through, h times x and h times h. We see here that we have 4 terms, but actually we can simplify it down to 3 because these two middle terms are the same. Yes, they're in different orders, but technically they're multiplying h times x in both cases, and multiplication is commutative, meaning the order does not matter. Therefore, what we can do is combine them. So we actually have a total of 2 xh's. So we have x squared plus 2xh plus h squared. Now that is just simplifying this first piece here. I'm going to continue on with the rest of it here in a white marker. So we'll do the rest of it down here. So I'm going to multiply the 2 through and then subtract 4. Let's take a look and see if we can simplify any of these. There's only one term with x squared, no other terms with xh, no other h squareds, no other just plain x terms or plain h terms or more constants. So this is actually the most simplified we can make this. These are the two main ideas that we need to be sure that we understand before we proceed with the difference quotient, because it can seem like a lot at once if we just go straight into the difference quotient. So make sure you understand what a greatest common factor is and how to factor it out, and also how to evaluate a function at really anything, plugging in a number, plugging in a variable expression. The difference quotient will involve plugging in x plus h into a function. Here is the difference quotient. Be sure that you get this written down. This is it. We will go into 2 examples and actually simplify this. It looks a little scary, but notice that we're plugging in x plus h into a function. We're plugging in just x into a function, just the original function, and we're subtracting 2 functions. We know how to subtract 2 functions, and then we're dividing everything by h. Okay, our first example is finding the difference quotient for this linear binomial here, this linear function. And I'll first write out the difference quotient, and we'll do a little color coding so we can see what we're doing. So it's f of x plus h minus f of x all divided by h. So I have a few different colors here. Okay, so this is the difference quotient. You should have this written down. Make sure that you know what it is. Now let's actually find what it is by plugging in. So the first thing that we need to do is actually find f of x plus h. So we're going to take this function and plug in x plus h to it. So when we plug in x plus h into this original function, we'll have 5 x plus h and then minus 1. So all I've done is find f of x plus h for this function. Then we're going to be subtracting f of x. Well, what is f of x? F of x is the original function. Here it is. It's 5x minus 1. Now we're subtracting something. It has more than one term. We need parentheses around it. So we're subtracting 5x minus 1 all over h. So all I've done is find f of x plus h, write down f of x, didn't need to find it, it's given, and we subtracted them all over h. So our next step is to just keep simplifying. So we'll go down here. I know it's still all over h. I'm going to simplify this by multiplying the 5 through, and then I'm also going to distribute or multiply this negative through. So we have a couple things we can simplify. So we'll have 5x plus 5h minus 1. Then we'll have, distributing the minus through, minus 5x plus 1. Again, you can see how easy it is to make minor errors here. So just be careful with distributing. Then let's take a look at our numerator and see what we can simplify. We have a positive 5x and a minus 5x. We have a minus 1 and we have a plus 1. So those actually all are going to cancel out. This 5x and minus 5x combine to 0. This minus 1 and this plus 1 also combine to 0. And so what we're left with is just 5h over h. Now, we don't need to do any factoring in this problem, but what we can do is realize that this h over h can actually cancel. There's no plus anything in the numerator or plus anything in the denominator. These are just factors standing alone, so they are able to cancel h over h, and we are left with the answer of 5. And that is correct. So the difference quotient, which in calculus we'll see is a derivative or a slope, is 5. Look at this line here. I'll let you in on a little secret. What is the slope of this line? It's 5. In our second example, we're going to find the difference quotient for a quadratic trinomial. And so for quadratic functions, they're not lines anymore, right? They make parabolas, and therefore they don't have a constant slope like a line does. So finding the difference quotient is a little more intense. As you can see, we're going to be squaring x plus h. We have a few more things going on here. So again, we'll write out the difference quotient, and it will be color-coded so we can follow along more easily. So we have f of x plus h minus f of x all over h. Okay, so let's plug in f of x, or let's plug in x plus h. So I'm going to plug in x plus h here and square it, then minus 2 and plug in x plus h here, then put a minus 3. So we'll have x plus h squared minus 2 x plus h minus 3. Then we're going to subtract our original function. So we'll do minus our original f of x, and again, it needs to go in parentheses just because anytime in math when you're subtracting something with more than one term, you need to put parentheses. All over h. Okay, so we'll continue here. In the beginning, when we did the prerequisite review, we squared x plus h. We squared it. And so when we squared x plus h, we did x plus h times x plus h. So I'm not going to go through that entire process again. We ended up getting x squared plus 2xh plus h squared. And that's because we did x plus h times x plus h. If you're confused on how we got this, go back to the beginning of the video and watch under the prerequisite and review. Okay, then we're going to distribute this minus 2 through. And then we have the minus 3. All right, then we're going to distribute our minus sign through. So we'll have minus x squared plus 2x plus 3. So be careful here. We're distributing this minus sign through. And then this will be all over h. This one's a little more complicated, right? But everything's going to cancel that doesn't have an h in it. So let's take a look at all the stuff that's going to cancel. We have a positive x squared and a minus x squared. That doesn't have h in it. It's going to go away. We have a minus 3 and a plus 3. We have a minus 2x and a plus 2x. So all the stuff that's remaining has an h in it. So it's 2xh plus h squared minus 2h all over h. Now here's where factoring out that GCF comes in handy. This is a little more complex than the first example where we just had one term over h. We have more than one term here. We can't cancel yet. What we have to do is factor the numerator, and our first step in factoring is GCF. What do these three terms all have in common? They all have an h. So h is the greatest common factor. So we'll factor out that h in the numerator. We still have our h in the denominator. And what's left? H times what gets us back to each term. So we'll be left with 2x first. Then we'll be left with plus h. Then we'll be left with minus 2. Again, if you need to check, multiply the h back through, and you'll get back to this original. All right, so we have factored out our GCF. Notice now that we have these factors by themselves. This is not attached to anything through plus or minus. It's only being multiplied. So we can cancel these h's now. See, we couldn't cancel them here because this was an expression with plus or minus in it. But now we can cancel h over h. We are left with what's in parentheses, which no longer needs to be in parentheses, 2x plus h minus 2. It's a strange answer. You're absolutely right. But this is the difference quotient so far. Once we get to calculus, we'll put limits with it, and it will tell us the derivative or the slope at any point, the instantaneous slope. But for now, all we have to worry about is the difference quotient. Common errors that can happen are not squaring x plus h correctly, not distributing negatives correctly, and messing up the GCF. Okay, I've included one more problem. I'm not going to work it out. I'm just going to show the solution. So if you'd like to practice this one on your own, go ahead and write it down, pause the video, and press play to check what the solution is. Our solution is 2x plus h plus 1. Now you know how to find the difference quotient.